In this video we're going to be looking at doing some factorising, particularly looking at factorising through grouping. So if we take a look at the first question here, we have 4 terms. So the key is to try and find common factors, and if we look at our first question here, you can see there is no common factor for all 4 terms. So what we can find though is a common factor for the first 2 and a common factor for the second 2. So if we take a look at the first one, there's a common factor of 5a. So if we take a look at that then, so that means that must be m plus 2p. If we look at the second set, you can see that there's a common factor of minus b. So minus b, put the other factors inside, which is m plus 2p. So what we'll notice with that is that this first bracket and the second bracket are exactly the same. So really we can just convert those into double brackets. So we can go bracket m plus 2p, close the bracket, and then the second bracket is just whatever's in front of the other 2 brackets. So it's 5a minus 2, minus b. So you can see with this question, it's really just an expression of the expansion of using the distribution property. So you can see that it would be 5a times that bracket minus a b times that bracket. So that's factorising by grouping. So it might be that you want to look that up on YouTube videos to get a better understanding of that one. If we take a look at the second part there, it's harder to see, but we should look at, we've got 2 terms here. We've got our first term here, and we've got our second term there. So trying to find common factors. So the common factor of both of them is you've got this 15 and 20. So we can take 5, but also we can take k plus g. So what that means is that if I take that out as the common factor, so 5k plus g, we can put what the other terms are, which would be 3 times k plus g, and then the last one would be minus 4. Now we can't leave that with our square brackets, so what we can do is just expand just this part. Oh, I shouldn't have put that bit there. That should be 4. So we can expand that part to end up with a nice second bracket with 3 terms. So we end up with 5 bracket k plus g. Then we end up with another bracket, 3k plus g minus 4. And that's our answer. The third part is recognizing that we have the difference between 2 squares. So if we take a look at the first one, and the clue is the 2 terms with the minus in between. If we square root 4x squared, we know that that would become 2x. If we square root y to the power of 4, we know that should be y to the power of 2. So we can put our answer as the difference of 2 squares. So it should be 2x plus y to the power of 2 bracket 2x minus y to the power of 2. So that's the difference of two squares, or factorising the difference of two squares. And that's anything where it is p squared minus q squared is always going to be equal to p minus plus q and p minus q. All right, okay, moving on to part B of this question. So this one's relatively straightforward. What the easiest thing to do is, it's just a slight variation of our normal expansion. You need to expand these two brackets or any of the two brackets first, and then do the last expansion. Doesn't matter what order you do. You could have done the first two brackets and then done the third last or whatever, but basically everything needs to be times by everything. So if we start off with this one, remembering our expanding rules, so FOIL, so we can end up with x minus 3, and then we end up with 3x squared minus 4x plus 3x minus 4. So again, we've got common factors here, so we can simplify it further. So we can end up with x minus 3, and in the second bracket 3x squared minus x minus 4. Then it gets slightly trickier. We need to expand these two brackets, so we need to take the x, multiply it by the first term, second term, and the third term. And likewise with the minus 3, we multiply it by all three terms. So if we just start with the first one, so it's 3x to the power of 3 minus x squared minus 4x. Then we do the second term of the first bracket, multiply it by everything. So that would give us minus 9x squared plus 3x plus 12. And then we can do our simplifying of common like terms. So you can see we've got an x squared there, an x squared there. We have an x there and an x there. So we can end up with our final answer of 3x to the power of 3 minus 10x squared minus x plus 12. And there's our answer. So for the third one, slightly trickier. The key thing is to really break down and try and use the properties that we know from our expansion. So if we start off by thinking about the left-hand side, what does that mean? It means that we have x plus a times x plus a. Now we should be able to handle the expansion of that, which would give us x squared plus x plus a plus ax plus ax plus the last one, multiplying the last two together, gives us a squared. So what does that, and then we can simplify that because of the common terms in the middle. So these terms in the middle can be added together. So we can end up with x squared plus 2ax plus a squared. So what does that mean? So first of all, looking at the right-hand side, it means if that's equal to that, then this must be equal to x squared, the right-hand side, plus 22x plus b. So what does that tell us? That tells us that a squared and b must be the same, but also 2ax and 22x must be the same as well. So if we can go back to this, then we can say a squared is equal to b. That doesn't really help us in answering the question, but we can use it later. But the second part is the important part. 2ax is equal to 22x. So we can solve that, and we end up with a is equal to 11. So we can put that as our answer. But also we can use this top line. We can use this top line here to work out b, is that it must be is equal to 11 squared, which is equal to 121, and that's our second answer. So there we go. That's how we answer those questions dealing with factorising and expanding.